All right, next up we have Benoit Claise, who is the Data Communications, Intelligent Operations and Management CTO over at Huawei, and he's going to teach us about how we can ride the waves of autonomous driving network one step at a time. Benoit?
Thank you, Rod. That's a nice title, right?
It is a very nice title. I wish I had something like that. Yeah. You just start talking and then they'll turn it on. Yeah.
Start talking and singing until the mic is on.
Yeah, you got to sing a song.
In this session, I want you to express how we could solve the ADN, or the autonomous network vision, once upon a time. So all of us, that's what we want to do here, right? Having networks that are going to be self-behaving. So whether you call that autonomous driving network, or autonomous networks, or intent-based networking, or self-whatever, it's the same thing in my mind. So how do we solve this? Once upon a time. And I would say in the research, in the prototype, and in the product in the end, without forgetting the standards. So every single time there's a problem, it's always a network. We always blame the network, right? However, it's never the application, right? The application is always works fine across the WAN, for example. It's never the server. The server is never overloaded. No memory issues, right? And it's never the cloud. The cloud works perfectly well. And it's never the end user environment, right? Obviously, I'm kind of being sarcastic here because the first thing that operator asks whenever troubleshooting end user is, can you please reboot and remove your firewall and switch and all this at home, right? The same thing like whenever the BGP route from Facebook disappeared, the operator were called telling your network is crap. No, nothing to do with that. My point is that we have a new definition of networks whenever we say the network doesn't work. It could be the application, the server, the cloud, even the user environment. Because in the end user cares about the QoE. And everything between them and what they want to do is the network. So the silo organization, they don't work typically, where you say, I'm going to focus on my domain only. Or maybe they will. Let me show you. But I'm somewhat technical, right? And for many years, we've been introducing in our routers, all vendors, many features. Those were cool, but actually we've been adding complexity. And this complexity is on the way to turn against us because networks are too complex to manage, too costly. And we arrive to a point where we say, if it works, don't touch it. I've got access lists. They should be working. I don't want to even know it works. I don't touch it, right? The big issue is that the ratio of OpEx versus CapEx is way too high. Whenever we spend $1 of CapEx, how many dollars do we need to manage that, right? It's pretty high. This is what we have to solve. But we know that automation is compulsory. We know this, right? And we should not forget that if a feature can't be automated, it does not exist. That's a basic principle. Now, on the top of the slides, everything that we want to do here is like take an action whenever the customer services are impacted. This is the main driver. This is where the money is. This is where the penalties are. So this is what we want to focus on. Now, if I look at the TMF architecture, something I like about that is that we could have closed loop at different levels. It could be at the resource level. It could be at the service level. It could be at the business level. So it means that somehow we have multiple intents at different levels, right? So what I want to focus on, this is on the bottom right-hand side, here, the self-assuring part, taking into account that everything we do is based on a customer impact. So self-assuring is self-monitoring, self-healing, self-optimizing. This is my way to enter the autonomous networking world. Now, if I take this figure with all the levels of autonomous networking, going from level 0 where it's only manual, you configure CLI, right? By the way, it doesn't work. Google mentioned like 10 years ago that if physically impossible to configure everything by CLI with all the frequency and all the big changes that they do. It's simply impossible. Layer 1, tool assistance. Layer 2, or level 2, partial autonomy, where we've got API-based programmable actions. Then we go to conditional one with L3. Then what we want to do in the end, this is L4 and L5, all right? The L5, I will lose some more hair whenever we get there. But I could just say, network, you just work. Yeah, but what does it mean, work? We need to get the intent for that, all right? But what I want to do is going slowly, pragmatically, step by step. Now, let's ask ourselves, where are we, all right? And that's the first question. Well, it depends. If I take the top right-hand side, we mentioned hyperscalers multiple times here. I'm guessing that there are level 3 or 2.5, because if they see a problem twice, just code it, right? And the cloud native that was mentioned in the panel is built with some level of reliability in there. So somehow, I would say 3 to 3.5. If I take data center, I would say 2.5. Some Huawei paper are telling we could prove to be at 3.1. I'm telling this is somehow a simplified problem. Data center are greenfield, perfect topology, always the same top of the rack switch from the same vendor with the same APIs, right? So it's a reduced number of platforms and OS. That means that I could apply my ML to it. Now, what is the most difficult one? And this is what we've seen with the panels and with the TIP must. The operator, the carrier, that's the most complex case. They are multi-vendor. You are multi-vendor. That's a fact. You've got legacy device. You've got sometimes new devices with new capabilities. You've got sometimes silo organization of support, right? All of these makes it more complex. So that's the one I want to focus on. If we're able to solve that one, data center will be a piece of cake, right? Now, if I look at enterprise, there is not a single enterprise type of customers, all right? You could have like a small enterprise, you could have a bank, etc. So it depends. And if I take the last one, the consumer, it's, I would say 1 out of 5, 2, but if you've got something which is a cloud-based application, it's obviously higher. So bottom line, this is what I want to focus on. And in the center, I have this TMF thing, where we've got all the levels, and we go into the execution, awareness, analysis, decision, and all this. And that's what we want to do, going to the right there, from something which is P, like people, for manual, to S, system autonomous. Now, I'm not going to try to convince you that you guys have a plan for digital transformation, right? This is a fact, whether you look in China, Europe, Asia, or the US. All of you, all of the carriers, they have a plan there. So Huawei initiated this L3 just-in-time program where we identify the high-value use cases. And somehow, I'm going to review that in line of the TUP use cases. And I like this approach very much, right, where the operators are telling in a common way their use cases. And obviously, most of us, we have the same use cases, right? We all pretend that we do an L3 VPN differently, but in the end, most of them have standard parameters, right? Now, API was mentioned multiple times. So we went from the first generation where it's like atomic interface to transaction APIs to intent API. And that's why I spent so much time, so much time on data model driven management with Yang. Because whenever you define data model, from the data models you can generate the APIs. Now, if you update those data models in a backward compatible way, it means that your APIs are also working. And we are now at the level of intent API. And with the principles of compatibility, simplification, completion, and decoupling. I will not go into the detail here. Now, going step by steps, right? I've been showing you architecture, which are top-down. I want to also do this bottom-up, because they have to meet somewhere, right? Whether you look at ZSM from yesterday, or TUP, MUST, etc., well, they should match. So this is like service assurance for intent-based networking. This is an ITF draft for now, working group. It's going to be last call soon. And that's a way for me to solve the service assurance. Remember, slide 1, service impacting. Then I do self-healing. And for that, service assurance. The top one here is the architecture. Well, we've got what? A Yang module. I see a Yang module, I see an API. That's key for me. And this flexible architecture could work with physical devices, virtual devices, multi-vendor. It must be a standard. That's why we did it in the ITF, right? And it could be multi-domain. So the point is that if I'm responsible for a domain which is core, I have to prove it's not my problem. My core works fine, right? If I'm data center, same thing. So we could have those service assurance per domain, but the thing with Yang is that you could group those graphs together. So we have a prototype there. I'm going to show you a couple of pictures, and we start to get the community here. So I believe that at some point in time, if we do a good job, that could be part of a TUP must ADN type of thing in the future. So let me show you this. So I've got a graph here, right? A graph for one service. At the top, it's the VPN service. And I'm telling, for this VPN service to be healthy, so for my customer to be happy, I need what? I need a couple of things below that must be healthy. So typically, I need, okay, let me forget about the picture. I'll show it here. So I've got my VPN instance. It depends on the right configuration of a PE1 router, a PE2 router, of connectivity between the two. The PE1 router and PE2 router must have the right QoS. They must have the healthy interface. They must have a healthy link between all of these. So the idea is to say, can I just assure components by components? And if those components are healthy, as a consequence, my service should be healthy. So I infer the health of a service based on the health of all the components. So which problem do we solve here? First of all, I'm able to see whenever I've got like an alert telling my service is not performing well in terms of KPI. I could see this graph and see that, well, my service instance is yellow here because I've got this bubble there. It's a VPN data plane which is not behaving the right way. Easy troubleshooting. But the value is also in the reverse direction. If I select now this VPN data plane, because I've got the graph in one direction, I got it in the other direction, it's going to tell me this specific subservice there, VPN data plane, is impacting X number of service instances. So it gives us a way to classify the top things that an operation team should be doing. Because this thing in yellow there impacts all of my gold customers, the one with penalties. Okay? So the key challenge with build solving is to get a set of metrics we look at and the impact on the service. Right? With this, we didn't work with ML yet. Why? Because ML needs, if I speak to data scientists, it's always, okay, I want a lot of data. I want more. High frequency, all this. I want to have labeled data. And then maybe I'll do something for you to start with. And by the way, I want all the semantic of those data. And I'm telling, yes, but if you don't have the intent, that will not work. So for us, this is a knowledge graph of everything, which is like service, instance, subservice, the symptoms, the KPIs, everything. So whenever we want to solve a digital map, and by the way, I could say we could be solving digital twin, but I don't like digital twin buzzword. Because if we believe that we're going to solve everything by doing emulation and simulation, it's not going to work. Specifically, whenever we'll go into the SLA type of verification, try to say, I'm going to emulate everything and expect to test my delay in this simulation. Doesn't work. Jitter, same thing, doesn't work. So I prefer to speak about digital map. So for us, we've got the first map, topology. Second map, underlay. Third, overlay. Service instance. Then service with the SLA. And the one above is like the alternate path that you could be finding. If my primary path has got some KPI issues, I could take a different one. Exactly like Google Map. I want to go to a restaurant, I'll take a car, there's an accident, I'm being rerouted. This is the thing, this is my way to solve, this is our way to solve the digital map. Now, this is about prototype. There is some aspect of that I research as well. But as we've seen again with TIP must, and that's a common sense, it must be standards. So for all of these, going from the left to the right over there, I'm giving you a couple of pointers. Top right-hand side, intent assurance. And by the way, I focused on the ITF to try to bridge the gap between the top-down architecture and the bottom-up. Then everything is about data model and Yang. So if we've got like non-backwards compatible changes, we want to document that. In here, we need to get the per node capabilities. So it's key for us to know if I could set a specific metric as on-change or not. On-change means only send me a new message whenever the value changed. Don't keep sending me all the interface counters if I don't need them, right? That we believe that we have to do every 5 minutes. And we need to expose this at runtime and design time. So we need as well. So we've been searching for a way to define those expert rules, right? And we looked at all the possible languages. In the end, we could not find all the requirements we needed. So we created our own assurance DSL. Because to start with, it's expert rules based. To start with, I want to stress that. I'll come back to it. The next thing is that if you think about solving ADN, you must have the full visibility in your data lake. About what? About everything that happens in data plane, including packet loss and delay and all this. Everything that happens in control plane. In this case, because I'm focusing in the core and fixed network, it's about BGP monitoring. And the third one, edge management plane with Yang. So we try to reduce this to three data models, IPFix, BMP, and Yang. Now, the key thing is that we are always overestimating how much we could stream out of routers. Data scientists, they want everything. I want microsecond granularity of all the counters you could get in a router. Beep, doesn't work. If I take a BGP Yang module, we have 50,000 leaves in there. If they believe they could have that all the time, streamed, well, think about it. So we need to get, first of all, to be sending all these counters with UDP like we do with Netflow and IPFix. Because if we lose a counter, it's not a big deal. However, if we lose an event, meaning I'm monitoring this status with unchange, that's an event. I can't be losing that one. It must be sent reliably, because that's my way in the closed-loop automation to take my input as an action. So, data manifest. If you think about the big data lake, you must have all the context in which you were metering the information. Because in the end, with all information in the data lake, we could use ML and AI on top of the intent that we have, and then we'll have a perfect solution. But we need to send, along with the data, all the contextual information on how it was metered, on what was the router OS, because maybe you see a change with ML, but you know, the router was upgraded. You solved a bug, or you introduced a new bug, right? And then some work done on segment routing v6 here. I think it will be a key enabler, because if you want to improve the NMS OSS, right? I've got 2 minutes, perfect. Then what you have to do is that you want to have the full visibility. And segment routing v6, if people move to that, it's because they want to lower their OPEX of managing network. As a consequence, getting the full visibility in segment routing v6, plus the intent assurance is the right driver. So this is like a sponsor type of presentation. So I have to do some product placement here. So obviously, we're working on this on the products. Contact me offline if you want. Done. Yeah. Conclusions. So we have to solve this ADN vision one step at a time. Okay. Intent is key. Doing ML and AI without the intent is not successful. So we have to do it domain per domain. So we have to think differently. Can we assure components by components, domain per domain, proving it's not my problem. My core works fine. My data center with all the ACMP, they works fine, etc. And with the assurance graph, we're able to infer the service health. Now, whenever we combine this with the real end-to-end probing, we've got the perfect story. Now to this, you add ML to improve all the expert rules that I introduced manually, but that are way too costly. Improving those rules, like finding new rules, telling new KPIs that are important I'll not be thinking of, getting the right threshold. Is it 5% of CRC errors that influence my service by 10, 15, or 50%? Right? Now this is the time to apply ML and AI to this. So with this, I believe we could be solving the ADN L3 by 2025. Thank you.